Hey y'all, it's Miss Rudd. Today we're going to be talking about simplifying expressions. So for the first part of this lesson, we're going to think back to when we used our colored counters, and we had our positive colored counters and our negative colored counters. Every positive and negative made a zero pair because they canceled each other out. That's going to be the same concept here when we're modeling with negatives and positives, and when we're recreating our new expression. So for example, this first one says negative 2x plus 3x plus 5 minus 1. That's a lot of information, so we are going to model them with our algebra tiles. So it has negative 2x, so I need two negative x's, positive 3x, so 3 positive x's, positive 5, so 5 positive 1s, and then minus 1, so 1 negative 1. And if you notice, we have all of these zero pairs which cancel each other out, and we are left with 1x and 4 1s plus 4. So this whole expression that they gave us here can actually be simplified down to x plus 4. Let's try this next one here. So here it says I have 7x plus 3x. So I'm going to draw 7 x's, 1, 2, 3, 4, 5, 6, 7, and then I'm going to add 3 more positive x's, 1, 2, 3, and I'm going to count up all of my x's that I have now, and I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. So my new expression is 10x. We're going to try one more, and then you're going to do the last two on your own. So this one says negative 4x, so I need 4 negative x's, 1, 2, 3, 4, and I'm going to color these in because they're all negative. All right. And then minus x, so there's another negative x, plus 2. So I now have 1, 2, 3, 4, 5 negative x's, so negative 5x plus 2. None of these cancel out because they're all negative x's. Go ahead and try the next two on your own. Push pause and then push play when you're ready. All right, so when we drew out all of our negative x's and positive x's and our negative 3 and our positive 2, most of them canceled out, and I was left with 1 negative x and 1 negative 1. So I have negative x minus 1. Remember, anytime you see just a variable, there's an imaginary 1 in front of it. This is telling me I have 1x. I just don't need to write the 1. So I have negative x minus 1. For the next one, again, I have 3 positive x's plus 2 positive x's minus or plus a negative 7x. So this negative 7x cancels out all of our positive, and I'm left with 2 more negative x's. So my answer is negative 2x. All right, so when we are simplifying expressions, we are making an equivalent expression to the one that we were given. It's just in simplest form. So when addition or subtraction signs separate an algebraic expression into parts, each part is called a term. The numerical factor of a term that contains a variable is called the coefficient. This is the number that's in front of the variable. A term without a variable is called a constant. And like terms are terms that contain the same variables, such as x, 2x, and 3x. Each of those terms contains the variable x, so they would be similar or like terms. All right, so let's label this based on the definitions we were just given. So each one of these is separated by an addition sign, and it says it needs to be separated by addition or subtraction. So here they're separated by addition, so each of these is called a term. This is the only one without a variable attached to it, so this one would be called our constant. And then these two numbers are attached to the variable in. So the number that's in front of the variable is called your coefficient. And then if you look over here, it shows us that there are three different terms here. This one, both of the ones in red would be considered like terms because they have the same variable. 3x and 1x are like terms because they both have the variable x. So let's move down here and practice simplifying our expressions without models. It says to simplify an algebraic expression, use properties to generate an equivalent expression with no like terms or parentheses. So our goal is to get rid of all the like terms and combine them into as few terms as possible. And we can use coefficients to help visualize how many of each term we have. So for example, here I have an x and an x. Remember I said that in front of each variable, if there's no coefficient, we pretend that there's a little 1 in front of it. So if you need to write that 1 to help you remember, go ahead and do that. But it tells us that we have 1x plus 1x. Well, 1 plus 1 gives us 2 x's. Over here, we're multiplying. So we have -4 times 6x. So that means we have 6 x's -4 times. So here we do -4 times 6, which gives us -24. And we have that x that we can't forget about. It's still attached. And two expressions are equivalent when the expressions have the same value, no matter what value is substituted for x. So -24x is equivalent to -4 times 6x. All right, let's try letter A. Here, it doesn't actually matter. We talked back about properties, and it doesn't matter what order we multiply in. And since we're only dealing with multiplication, and I can't really combine the 3 and the x, I can switch this order around and do 3 times 11 times x. And then I get 33 times x. And remember, another way to write multiplication is just to put those the number and the variable right next to each other. So our simplest way to write this would be 33x. For this next one, I have x plus x plus x. That's 1, 2, 3 x's. And for the last one, I have two like terms here, 7x and x. I can combine those. 7x, remember there's an invisible 1, so 7 plus 1 gives me 8x, and there's nothing left for me to combine that 8 with, so it's going to be in the back by itself. So 8x plus 8. We can also use properties to help us simplify expressions with two variables. So for example, this one has x plus y. Now remember we said that like terms are terms with the same variable. So we cannot combine this x and the y because they're not like terms, but we can combine the two x's. So here we have x plus x, which gives us 2 x's plus 1y. And that's our simplest form. Over here, we have the distributive property that we learned about not too long ago. And remember, we need to distribute that outside number to both of the terms inside. So we have 4 times 2x. 4 times 2 is 8x plus 4 times 1y, which is 4y's. And that's our simplest form because we have no more like terms. Alrighty, moving down to the bottom, I'm going to do the first one with you, and then I want you to try the other two on your own. So here we are adding. Again, adding does not matter what order. So we can rearrange this and say 14y plus 22y plus x. Well, 14 plus 22, they both have a y next to them, so they're like terms, and that gives us 36y plus x. And that's my simplest form because I have no more like terms. Go ahead and try B and C on your own, and then push play to check your answer. All right, so I rearranged B so that my x's were next to each other, added those together, and I got 5x plus 9. And for C, I used the distributive property. 7 times 3 is 21x plus 7 times 1y is 7y. Okay, we have a whole page. I'm going to do the first few with you, and then I will let you pause the video, try them on your own, and check your answers for the rest. So we have 3x plus 5x. 3 plus 5 is 8x. Here, 8m minus 5m, like terms. 8 minus 5 is 3, so I have 3 m's. All right, go ahead and try the next one on your own, and then push play when you're done with the next one. Oops. Your answer for this one should have been negative 3y. You can actually try the next one on your own as well. Push play when you're done with the next one. All right, for this one, we have 3 plus 2 is 5, plus 7 is 12x. All right, here is where we start having two terms that we can't combine. So we have a 5k minus 8k. Those have like terms, so we can subtract. 5 minus 8 gives us a negative 3k, and then we're left with that 7 all by itself that we can't combine. Go ahead and try the next few. Just try the rest on your own and push play when you're ready to check them. All right, so you should have gotten 8x plus 6. The next one was, I think, the trickiest. You should have gotten negative 18p plus 6. Keep in mind that this is a minus 2p, so we have negative 16p minus 2p. When those combine, we are subtracting 2 from a negative, so it's going to go farther left on the number line to give us negative 18p. Then we have 16m minus 7 and 5y plus 2. If you have questions, make sure you're coming to tutorials, and I hope to see you soon. Bye.